Good afternoon, and welcome to the fifth webinar in the e-construction series entitled Gathering Documents versus Gathering Data. The series is part of FHWA's Everyday Counts initiative to spotlight existing e-construction technologies. My name is Alexa Mitchell, and I am a consultant with WSP Parsons Brinkerhoff. I will be moderating today's webinar and introducing the speakers. But before I introduce the speakers, let me give you a brief overview. And let me remind you that this webinar is being recorded. On the screen you should be seeing the agenda for today's webinar. We will hear from 2 state DOTs, and we will conclude with a moderated Q&A session. I'd like to take a moment to introduce our speakers for the webinar now.
Hey Alexa, I'm sorry to interrupt, but your mic is a little muffled. Can you just move it away from your mouth?
Sure. Does that sound better?
Yes, thank you.
Thank you. All right, our first speaker is Paul Wheeler. Paul is part of the Technology Advancement Team at the Utah Department of Transportation. He has worked in many capacities within the UDOT for the past 19 years, serving as Survey Technology Advisor, lead of the 3D Visualization Group, CAD Support Specialist, and Construction Surveyor. Also joining us from Utah DOT is Tyrell Wood. Tyrell is a field engineer residing in Cedar City, Utah, with his extremely talented chef of a wife, Janelle, and their 3 children. He has worked for UDOT for 2.5 years, and his spare time he enjoys fishing, hunting, and playing a good board game. Before coming to UDOT, he worked for IBM as a project manager and began his career at Leslie & Associates, working as a project design engineer, surveyor, and project manager. His most recent success, along with a very talented team, was on the SR-20 Passing Lane project, where he helped train and coordinate the new IDC process in a real-world setting, which they will be talking about today. Also today, we have a couple of individuals from the New York State DOT, Phil Bell and Brett Dean. Phil is the Chief Data Coordinator and SIM Chair for New York State DOT Interdepartmental Working Group. Phil has worked for the New York State DOT since 1992, and he has worked on several major notable public works, such as the Kew Garden Interchange, Route 9A West Side Highway in New York City, and Outer Harbor, Buffalo, New York. He has a bachelor's degree in landscape architecture and in environmental science, as well as a master's degree in public administration. He is heavily involved in advancing SIM practices through his participation in several TRB committees, including the VDC SIM Subcommittee, AASHTO, and several NCHRP panels. Brett Dean works in the Automation and Technology section for the New York State DOT's Office of Construction, providing vital review and coordination activities and oversight. He is responsible for field support of all survey operations and CAD support on construction projects statewide. Brett worked in the construction industry and the private sector from 1986 to 1993, and also in the consultant engineering field. He has served in New York State government since 1993 as a construction inspector on a variety of projects. After the events of 9/11, Brett worked for New York FEMA in the Mitigation Division, procuring federal funds for various projects. We will conclude today's webinar with a moderated Q&A session. Like I mentioned earlier, this is the 5th webinar in the e-construction webinar series sponsored by FHWA and the Michigan Department of Transportation. There will be 3 more webinars in the winter of 2016 and 2017. Topics were developed based on feedback we received in previous webinars and other EDC3 deployment efforts, such as the peer exchanges and regional workshops. You can keep abreast of developments in the webinar series and locate the recordings of all these webinars via the eConstruction Today website, which is listed on your screen. Okay. I'd like to encourage you to participate in two ways. One, by answering the polls, and two, by posting questions or comments. On the screen, you have two sets of questions. Please take a moment to respond to the polls. It is helpful to us to know this information as it puts our other polls responses into context and helps us tailor our outreach to ensure we're meeting our intended audience. We really appreciate your participation. We'll give you just a few more seconds to respond to those two questions. It looks like the responses are slowing down, so we are going to take those polls away in a second. Okay. I also like to turn your attention to the Q&A pod. You should see the Q&A dialog box in the center left of your screen. Please make sure to post your questions here anytime during the presentations. We will hold questions until the end when we'll have the moderated Q&A. We will not be holding a live Q&A, but we will be monitoring this Q&A pod, so please be sure to use that dialog box to get your questions in the queue. Before I turn it over to our first speaker, let me open the next set of polls. You should be seeing on the screen two questions. We appreciate your response. Excuse me, we're hearing some noise in the background. Can we mute that line? We'll just give you a couple of more seconds to choose a response for those questions. It looks like the responses are starting to slow down. And we'll take those away in 3, 2, 1. Now I will turn it over. Go ahead, Paul. You may start.
Oh, go ahead, Alexa. All right, hello everyone. Thanks for having us here today. This is Paul Wheeler with the Utah Department of Transportation. And then also on the line is Tyrell Wood. And Alexa already read the bios for both of us. Tyrell is going to be available for the questions, and then I'll be doing the presentation for what we're going to talk about today. And hopefully you can get in a little more of the technical details if you have questions on those that I may not be able to answer. But today we're going to talk about paperless documents versus digital data, and then also the digital data advantage. And then want to talk about how we use digital data, and then also digital inspection techniques on our SR20 project. And the SR20 project was actually the first project that we had where we actually used the 3D model as the legal document instead of a paper plan set. So that was kind of a big goal and a big paradigm for us to do that. And we'll talk about a little bit more in detail on that. And then finally, I'd kind of like to talk about what our goals at the Utah Department of Transportation are for the future in using digital workflows in construction. All right, so first of all, paperless documents versus digital data. So I know in the past we've talked a lot about we need to move to e-construction. We need to move to E instead of doing paperless stuff and move on with that. And paperless documents, they've provided great value. I mean, for one, think about the space that you've saved where the paper once occupied. We used to have filing cabinets just full of paper, and they take up a ton of space, and we've been able to utilize that space a lot better now. So since we switched to using paperless, it's allowed us to index our documents. It made us easier to find things. There's less chance of losing something. So, and then also, I mean, there's the big thing of people, how many times have you actually spilled a drink or ruined some of your documents and it was the only copy you had? So by going to paperless, it's provided a huge value for us. It's also been a lot easier. It created the ability to share copies with just the click of a button. And even though the paperless is great, it's kind of time to take it to the next level, we've decided, and we want to kind of provide what the contractor needs. And what that need we've determined is the digital data. And what the digital data provides is it's intelligent data, and it provides a complete picture of what the intent really is. This is what their machines are using. This is what they've been asking for. So it's really made a change in how we've done things, just kind of taking it to the next level. So let's talk about the actual data advantage here. And the advent of paperless technologies, I mean, it's helped to enable great things like I just discussed. And we're able to utilize benefits where we never thought possible when using paper alone. And for one, I mean, think about in the old plan sheet days when people would photocopy things, and the more they got photocopied, the worse the picture got. So with the paperless technology, it's enabled us to give a fresh, crisp, updated copy to whoever wants it as well. So it's been great benefits. However, when all you have is a PDF plan sheet, it's still just a plan sheet. There's not any data behind it. There's no intelligence behind it. It's still just a 2D plan sheet. And even though it's fixed a lot of other things, there's more that you can do. And our vision here at the Department of Transportation of Utah is to do away with plan sheets where possible. So we've been looking at ways to do that, and we figure by actually using the actual digital data used in design that we can provide those files to the contractor, which is going to allow them to use those on their equipment. And the contractors have been creating 3D models from our 2D plans for quite a while. And I mean, we've already got those from the designer. It just doesn't make a lot of sense. They would take our 2D plans, they'd scan them up, they'd take a 3D model, create it from there, compare it to the plans, and all this was already created a lot of times by the designer. And why not provide those files to the contractor so we can save time and also improve efficiency? And then also, why do we need to introduce more errors in the design than's necessary? So that's kind of why we decided to move forward and utilizing the digital data within our department. And the first one for that was the SR20 project. And with that too, I mean, with the plan sheets, our designers weren't taking the design 100% because they had to put most of their time on the plan sheets. So by utilizing most of their time to do call-outs and other things, if we take that away, they can spend more time in actually creating a better 3D model. And that's what we've tried to do with this SR20 project.
I'm doing my work.
Okay, so the SR20 project, if you can all see this picture here in the webinar, this is kind of an aerial view of what it was. And you can kind of see the passing lanes there. This is when it's under construction. So the scope of this project was to use the digital data or the 3D model as the actual legal document instead of a traditional plan set like we've done in the past. And not only did we use the digital data on this project, we also added the use of Masterworks to implement digital inspection. So it's kind of a two-tiered thing that we did on this to see what would happen. And the reason that the SR20 project was chosen was, for one, there was a lack of design complexity and also a limited number of design disciplines. And this kind of resulted in a reduction in risk. So we looked at all the different projects and then also the regions that were willing to do things. And Region 4, which is our southern region, has been very proactive and volunteered to take this on. So with the reduction in risk associated with some of those elements, and then also to further increase the likelihood of success, we used CMGC, or Contract Management General Contractor. And this was used to allow kind of a back and forth between the contractor and the design team while producing the 3D model package as the legal document. We wanted to make sure we had that collaboration to see what the contractors were really going to need, and to help us understand how we could make this a successful project. And by utilizing this technology, we achieved a great success on this project. I mean, the project did cost more than probably what it would have been for a design build. However, the benefits and experience from it was invaluable. It was allotted a 90-day duration. However, using the digital data and also digital inspection techniques, we had a time saving of 25 days on this job. They were able to complete the project early, and it only took 65 days of the 90 days that they were allotted. And we'll kind of go over some of these in more detail, but by utilizing this new technology, we achieved great success on this project. It did cost more, like I said, than a design build, but the benefits and experience we found was invaluable. So by utilizing the new technology, like I said, we've seen a lot of significant improvements over the traditional methods. And one of those areas where we've seen a huge time savings in efforts was the digital inspection, and then also the data-driven forms. So data-driven forms, what we did is we just recently implemented Masterworks and to use for our construction inspection. Now, we're not using all the modules of Masterworks, but we used some of the digital daily diaries, and the SR20 project used this extensively on the projects and seen many areas where it increased productivity. The project team estimated that they saved over 50% on paperwork over a traditional project. And by using the data-driven forms, the inspectors were able to complete their daily reports electronically, and they're able to integrate their pictures and their reports. And when they reached an area where they had a Wi-Fi signal, it would be uploaded to a server, and this helped prevent any lost reports or spilled drinks on the daily diaries or other things that may have happened to them in the past. Now, one of our key things that we were looking at on this project was in a remote area where a lot of our Region 4 areas are, and internet access is really sparse in those or not available, and we really needed a tool that could be used on a tablet without internet service at all. And I mean, this is imperative to making this successful. So luckily Masterworks had the ability to put in all your data, and then when you get into an area where you have internet, then it would upload it into the server. And I mean, this is a big thing for our remote regions, because where we have our highway corridors, sometimes the main interstates, we've got internet, but a lot of the other regions are in that we don't. So that was kind of another area that increased productivity, was to look up pay items in the field to help with inspection. I know Tyrell commented that that's one of the areas that he used that helped him too. So by utilizing the Masterworks, being able to use it for inspection, have the guys put all their data into it instead of having to put data on this piece and then get it in. By collaborating and putting it all into an integrated method, that's where we kind of seen that 50% savings on our paperwork. Okay, somewhere else too that we kind of changed is the inspectors were able to check the grade on here on demand, and they used a GPS rover, and this rover was provided by the contractor along with the training. And what we did, we kind of have a new survey spec that came out, and for that we required the contractor to provide a rover as a tool to our inspectors and then provide that inspection. And then also not just a rover, we says we need you guys to provide the tool that we need. So if they're checking grade, like here on subgrade, as you see in the picture, a GPS rover is going to work well. However, if you're using your concrete and you want to check the grade, obviously GPS isn't accurate enough for the tolerances we require. So we asked them to provide a total station to help with that. So that's one way that we've kind of got around providing our crews with a rover for each crew like we had in the past. So we figured the contractor is easier to provide that and put that on the project and also the training. So, and it seemed to work really well on this project. In fact, one of the areas where it really helped with productivity and also accountability, so there's an error discovered actually by our inspectors using the rover on the grade. And what they'd found out is the contractor hadn't checked into the control on their machines in 3 weeks. And the error was actually due to the blade wearing down on the grader. So that was caught by our inspector, and what they found out is they actually had 3 more inches of material than what they should have been laid down due to the error. But luckily, due to this process, we were able to find that and fix it. So by giving our inspectors digital data and the tools to utilize it, we're seeing a huge change in the way we do business. We're able to get our projects completed faster, and it's helping create trust and also lasting relationships with our public. Okay, so kind of on this project I talked about replacing the paper plans with the 3D model, which is a huge step for us. I mean, we've been doing 2D plans since the beginning, basically. And we were looking at all the processes, we're talking to the contractors, and we're trying to find out where we could help. And what we found out is by replacing the paper plans with the 3D model that we were able to see significant improvements in our process. So we're able to give the digital data to the contractor so they didn't have to create it from scratch, scanning our 2D plans. And by doing this, they had the same model that we were using. Instead of taking the plans, scanning it, taking it into their software, and then making sure it was right when we already had a design. Like I mentioned earlier, we were able to focus on the 3D model, talk to the contractor, get exactly what they needed, and then by us delivering that model to them in a manner that would actually work in their machines, it created significant improvements in the process. So on this project, we did encounter some errors. I mean, it wasn't all good things that happened, so we obviously seen some good things, but we're actually hoping to see some errors, and that's kind of why we did this, because if we don't see errors, then we don't know to fix it. So in the beginning of this process, we're hoping to see a lot more errors in the beginning, then we can fix those quickly and then find out what we don't know. So some of the errors that we had in design on this one was actually due to some survey problems that we found. So on the terrain on this, it was pretty rocky, you had some really steep slopes, and we found out that the survey had some serious issues on there, which would require a change order. Unfortunately, we didn't catch it until later in the process, which we're now got a new spec together to hopefully fix that by actually creating a confidence report, so we can actually tell how good the topo is, what the density of the triangles are. So that's one way we're trying to leave this from happening in the future. So with this problem, it actually required a change order, but typically a change order would take about 2 weeks to process. And then due to us using a 3D model and design, it's able to easily be changed and sent back to the contractor for the machines. And what traditionally would have taken 2 weeks only took 2 days, so we had a huge time savings on that by just being able to feed that 3D model. So we fixed the survey, we had our designer rerun the model, sent it back to the contractor, and they were able to get up and going. And by that, we were also able to give that same model to our inspectors, and they could use that on their digital devices, so they could see the same model that the contractor is using to build the project to inspect off of. And the tool we used for this was Bentley Navigator, and well, the tool's not perfect. We did have some issues. It's in its infancy, but it was the best one we could find at the time to use. And as of right now, we're still trying to find that perfect tool for our inspectors to kind of have that 3D model in there. And we have high hopes for getting something there. In fact, we had a meeting with Bentley yesterday, and it looks like they're really moving forward with Bentley Navigator, so we have high hopes that that may be the tool. However, really, the only thing we see that's really going to push this method is by getting feedback from our contractors and then also other DOTs in the industry. And what that's going to do is create the tools that we really need. And on this 3D model too, what's great about it is you can actually put attributes into the model. So for instance, you can kind of see the 3D model picture there. We could put on a sign, what type of sign it was, what the size was, what type of post it used, what type of guardrail was being used. So it's not just a 3D model, but it is a smart 3D model with the digital data that's integrated into it, so the inspectors are able to click on each piece and see what it is. So instead of having traditional call-outs, there's intelligence actually in the 3D model. And this really made for a better way of inspecting. And like I said, it wasn't perfect. We did have some issues with translation there from MicroStation into the model, but hopefully in the future we'll see the efforts and all this come to fruition. Okay. So our future vision for data integration is right now we're trying to really discover new ways of innovative technology that can really help us move forward. And our goals are to continue using data-driven forms on our projects and then also to advertise with the design bid build projects. So we've done the CMGC, and we'd really like to try and do this with design bid build, and we're working towards that. And we see that there's some potential disaster that may happen from that, but we're hoping to try and get some of those errors and see them in the beginning so we don't see that. But even if we do have problems, at least we'll know what those are and we can fix them in the future. So hopefully we are able to do a design bid build project with the 3D model as the legal document. We also envision in the future to eliminate paper plans where possible, and we realize not everything can be eliminated right now, but eventually we'd like to. We see the vision where that's probably not going to be needed anymore. And we hope to also equip all our inspection teams with tablets and mobile devices so they can fully utilize our digital inspection tools. And then our ultimate goal with all this is really to create a living database of our infrastructure. And this will enable us to update the database with each change. So as some of you have been tracking us, we've been basically driving our roads every 2 years using a company called Manly and scanning basically with LiDAR all of our highways because we had no idea what was all on our infrastructure. So by doing this, we're able to complete a database of what we have, an inventory. And we only see this method here of increasing that. So every time we have a construction project, we'll have the contractor get the as-built, get the attributes out, and then feed it back into our database. When we have maintenance go out, they're going to update the database. So we have a living database so we always know what's out there, which is hopefully going to prevent us from having to scan with LiDAR every couple of years and then just scan little pieces that we need to. And this will allow us to know exactly what we have in our roadway systems, both above and underground. That's always up to date. So we've also created a utility database, and we're going to start collecting everything underground. That's one of our requirements, is to have the contractor collect everything that's underground from now on, so we can start to build a database of our utilities, which we don't have at this time. So as I said before, we face problems during this phase. However, we hope to find more problems and to enable us to find more solutions, to find them early on, keep the momentum moving towards our goals of the future. And we believe this truly is the way of the future, and we hope to discover the means to get the projects completed under budget and in a faster time frame. And what we've seen so far with this technology has been the pathway to achieve that. And industry has not completely caught up, and there's definitely some roadblocks. However, it's going to be really interesting to see what the future brings for all of us as we move towards this as a goal with each of us. I just want to kind of end on this last piece, so about the future. Albert Einstein kind of seen this, and his quote, he says, "The world as we have created it is a process of our thinking. It cannot be changed without changing our thinking." And I'll just end on that.
Thanks, Paul. Before I turn it over to Phil, I'd like to take a moment to post another set of questions. On your screen, you should be seeing 2 more questions. We'd appreciate if you can post your responses.
Once you start working in it, you got to do the process all over. Like if you turn a level on or off, you turn a level on or off, it blows up.
It looks like the polls are slowing down.
That process over.
And so I will turn it back to the presentation. Thanks everybody for responding to those polls. Now let me turn it over to Phil. Phil, you're on.
Thank you, Alexa. It's a pleasure to be here today to share what New York State DOT is working on in the field of e-construction and civil integrated management, or CIM. We refer to CIM and e-construction as intricately linked and very closely integrated. So at times, if I mention the word CIM, I'm also going to be, you can understand that as being part of our e-construction process. Some of the things that we use for e-construction, such as site manager, project-wise, contract manager, etc., are tools that help us with our process. And we use those tools to help us utilize 3D data and other data that become geospatially integrated or fully integrated into a more seamless process. So we've been working with 3D data for a few decades now, especially in design. You want to move the slide, Alexa, please? Where is that, us?
Okay, so you can advance it yourself.
Okay, thank you. So the value of utilizing 3D and E data continues to grow in New York State DOT. From our earlier days of using 3D data in design for analysis, visualization, public involvement, and construction phasing analysis, to now a more fully civil integrated management and E-data seamless approach. Our CIM goal is to seamlessly utilize and transfer 3D CAD design model data to construction for continued use throughout the construction process through completion. At that time, we'll be receiving an as-built for asset management purposes, and we'll utilize that data even further downstream in other tools, such as agile assets, and then share that data further with planning and programming for their use. So that's our construct and the concept that we have set up. An important driver has been the downstream customers, though, such as construction and our contractors pulling the data. So by wanting that data, it's really changed our approach and how we provide that data to meet their needs. And better IT tools have allowed us to more closely integrate the data electronically. We believe that this approach creates far greater value because this data is such an important asset, and we are in the process of measuring exactly what that value is. But I'll talk more on that later. So as an example of some of the projects that we are incorporating the use of e-construction and CIM on, there are some important areas that we are learning from with these particular projects. So one of those is the new New York Bridge, otherwise known as the Tappan Zee, and the K Bridge. Both of these projects are design-build projects. I'll discuss some of the other project examples in a few more minutes. So New York began to collectively focus closely on e-construction and CIM when we were asked to participate in an NCHRP domestic scan 13-02, Advances of Civil Integrated Management 3D Modeling for Construction. In preparing for that meeting with the Scan Tour team, we learned that in New York State DOT we had several pockets of expertise and that we were not taking full advantage of this expertise internally. The graphic on the slide illustrates our conceptual model, and it builds off the conceptual model that was established for the Scan Tour, and we've enhanced it somewhat for our purposes. The model highlights sharing data as a value-added construct, and it is a continuous cycle. The benefits that we foresee with this are better quality of the data. That means, and quality for us
We
means
lost
it's
you,
relevant, it's accurate, reliable, complete, and accessible.
Back.
Although a full session on just this topic could be done alone. We also feel that the benefits include better communication, coordination, and collaboration, and we address this data as a significant asset, and it's driven by the customer chain of value approach. As an important step, we also established an enterprise-wide civil integrated management work. This group really becomes a guiding coalition for us, and there's over 30 members in DOT that are part of that working group, including FHWA. This was an important milestone, and now that we had a forum for sharing knowledge and expertise, all of those areas that we identified in the Scan Tour. We meet quarterly, and people actually want to come to this meeting because of the value that they get from it. The SIM working group can be described as our, as I mentioned earlier, our guiding coalition. At first we identified over 45 issues that we would need to address, such as how does FHWA accept for our information, 3D information for reviews and approvals, and how do we get other control agencies to accept the models. All the way down to, I won't list all of those items that we identified, but there are several critical path implications, accuracy requirements, and sharing the data to other systems. So the SIM working group, much like the strategic approach that we have for SIM, improves our communication and our ability to share what we are learning and develop better processes. Important drivers, other than our construction and contractors, are asset management group. As the customer for all of this data, our asset management group really has driven how we specify the data that we will be providing to them. Other important drivers have been the Everyday Counts program and the wealth of information and guidance available. Our hats are off to FHWA for being such a champion in this area. And funding opportunities such as STIC grants, aid grants, Sharp 2 grants, and things of that nature.
All right, and I'm going to speak a little bit about the construction end. The first thing we needed to do is define electronic engineered data. Basically, what we determined was the electronic engineered data is had 3D elements for design that have attribute data, the level of the materials, all the construction details, length. They could be designed separately but viewed in context, meaning you have different designers working on different sections, you put it all together and look at the big picture. And we noticed that when we did this, it had value at every life cycle, or every step of the life cycle. It had value in design, in construction, in operations, planning, and right then in design. everyone's using the same data for the same purpose, and if everything works right, we'll be able to collect a very accurate as-built in construction and put that back into the mix so everybody can use the actual data that's out there. The electronic engineered data that we used is based for construction operation and inspection for items that are represented by points, lines, surfaces, and volumes. Basically, our points would be our sign locations, drainage inlets, etc. Our lines would be guide rail, right away, anything we can determine that we have to collect in a line. Our surfaces could be for quantities. If we do a surface-to-surface computation, we can come up with a quantity based on a before and after. And some of our that's for our volumes. Our surfaces would be more seed and mulch, establishing turf, etc. This leads in a more stakeless layout for the contractor. And as inspectors, we need to have the tools and the technology to be able to keep up with them. We found that out a long time ago. We've had GPS equipment in construction since 2005, and we've been using it very well, in my opinion.
We lost you.
We have a CAD survey coordinator in every region. We have 11 regions plus a main office. We all support each other. If somebody in Syracuse needs a hand, somebody from Utica, Watertown, Rochester, or Binghamton will go support them. We have a pretty good network together. We're all using our GPS equipment, total stations, digital levels. We actually have terrestrial LiDAR in-house. We're moving into exploratory data with UAVs and mobile data, or mobile LiDAR. We're using the technology. We're getting a lot safer out there, less injuries, less accidents, less fatalities, better cooperation. We have to talk to the contractor has to talk to us. If we have an issue, we both have data sets we can share. I can show you what we have, I can show us what, or you can give us what we have. And what this all leads into is the dynamic data updating for as-built conditions. The reason we want to have an accurate as-built is our asset management group has data mined our as-builts to find their asset locations, installation dates, all the information they need to feed Agile assets. We had Bentley help us with that. They created an underbar Z level, so when our inspectors out there with a GPS unit collecting the attribute, they just have to make sure they designate it with an underbar Z level, and when they import it in a Bentley, it'll go right to the correct as-built level for us. And some of the purposes we've been using it for, as I mentioned, is location verification, measuring quantities. We find we're getting better use of our staff. Everybody's running the same problems. We don't have enough people to go out there and do the work that we did before, so we have to give them some technology to make it faster, more efficient, more accurate. We get real-time independent verification of all the information, whether it's installed or to be installed. We reduce our calculation errors. We have a surface we collected. We can do a surface-to-surface computation, come up with a quantity, and that's where we're coming up with no errors and double payments, because we're collecting it, and we have a model like we're going to do on our Kew Gardens project. The model is going to be the record, the project record, which will also be updated continuously to include everything. So that model will actually be our as-built. What we're doing is we're collecting the data to support the information in the documents, and we're using Site Manager. We have a couple vendors out there, Appia and Fax, that are also doing it. We are using tablets, our smartphones, and computers. We put high-speed internet in all of our offices, all of our field offices. So we're really trying to move the technology forward. And some of the benefits of finding that there's less time spent waiting for the surveyor, the contractor surveyor, to show up to lay something out, because the operator is really controlling the operation now. He has GPS in his machine control guidance machine. He can go over, he can check control, he can make sure he's hitting right. That's one thing we request, is check in the morning, afternoon, or at noon, and in the evening, make sure that you didn't lose GPS, you're going off the intended design. Grade formants, we really don't have a grade foreman on every operation anymore, again, because the operator is controlling the movement. This all leads in a better stateless construction, less time for the contractor, less layout for the contractor. We can verify it easily and readily with our equipment.
Thanks, Brett. I just wanted to go from here and just take a few minutes to speak about the Everyday Counts program. This has been very important for New York State DOT, as I mentioned earlier. For New York, we've recently created an external website called our innovation site. And on that site, we have most of our Everyday Counts information, including the stick and our stick corner, things that we've accomplished, including our fact sheets, and an area called thought leadership. Everyday Counts has been very important to us because it has provided us with tremendous guidance. And this slide just highlights a couple of some of our fact sheets that we have on the site. So examples of 3D and 4D, 5D modeling, or SIM, and e-construction are being used to manage several projects right now on our various construction jobs across the state, and we've completed many work activities using the modeling. E-construction and SIM provides great opportunities to accurately visualize and share electronically the work that's being involved. And as this slide illustrates, it demonstrates the power and effectiveness and value of 3D data for things such as more accurately checking conflicts, such as utilities, compared to conventional methods. Field collection of utilities is an ongoing process, along with GPS positioning and other data capture methods during inspection. And the data is entered seamlessly for analysis and coordination. So where are we going with this technology? And one of the important things is that the advantages of using SIM and 3D digital technologies along with e-construction have been demonstrated to provide significant benefits. Now these advantages and benefits have been identified by FHWA, and this slide shows the many that have been identified. One of the things that in New York that we are trying to do is we are measuring performance data on our projects to increase the breadth of the analysis and look at further support to validate these findings. Now I'll get into a couple of projects. The first case study that I'll discuss is the I-87 project over Albany Shaker Road. It's a $22 million, or was, a design bid build project. This particular project, we used the modeling for AMG purposes. So it was very effective for the contractor. As you can see by this slide, this is a photo taken from the actual construction field office, and it illustrates the various data, ways it is organized, and what work is scheduled for that day, including what specific sequencing is going to be done. The 3D model data corresponded very well with the planned work, and as it was programmed into the equipment, AMG was the process where the equipment would just follow along with the modeling. So it was a very important process for us to see, and we spent a lot of time out in the field just watching how that would work and to see what the developments of that and the benefits would be. As you can see in this slide, this is one of the actual pieces of equipment using the modeling as it was entered in the morning. And you can see now that the twin GPS sensors, as opposed to earlier days when they had maybe one GPS sensor on the blade, it provides more accuracy for the equipment. I know that particular day when we were out there in the field, it was these temperatures were reaching 95 degrees. And at the same time, we had Alabama DOT there for reviewing the project in the field. So it was there was a lot of good information shared at the time. So how did we do with that job? Well, the project was completed 7 months ahead of schedule. It was planned for May. The completion was planned for May 25th. It was actually completed in November in the year preceding that. Construction costs were on budget, and we had one field change due to an unknown, unanticipated field condition. But interestingly also is that this particular project won the 2016 AASHTO Best Use of Innovation Award for small projects. So we're very proud of that project. The next project I'll discuss is the K-Bridge, or Kosciuszko Bridge. It's a replacement project, replacement bridge down in New York City, and it is a $555 million project. Again, this is a design-build project. So what's important about this job is we also, because of the design-build nature of the project, it's a very complex project. It's yet we're using many innovative techniques for the job. So construction started in 2014 and planned completion date is 2017. This slide shows that we are using, as an example, 3D data used in the modeling for 4D applications as well as 5D applications. So for our purposes, we define 3D or 4D, excuse me, as scheduling and time-based data, and 5D is cost that is linked with the 3D modeling and 4D modeling. So this project has been going very smoothly. So far, no orders on contract have been necessary.
Yeah.
So that's been a good indicator for us.
This is Alexa. Would you like me to show the video?
Information related to the K-Bridge. You can see, yes, Ches?
Okay, thank you.
Yes, not on this slide, on the very next slide. Okay. Yeah. So with this slide, it shows a screen capture of the actual 3D modeling and actual construction images that are representing the data that's in the image. And you can see the level of detail in the image. And I'm getting some feedback, Alexa. I'm not sure if anyone else is hearing that. Can people check their microphones, make sure?
Yeah, there's one of our participants has joined on a phone line, and please mute your mic. We're hearing your conversation.
So, as I was saying, with this particular image, the level of detail in the actual data model and the 4D and 5D modeling it's important to capture enough detail that you can see the work that's being progressed and in the time frames that it's being progressed, but it's not necessarily to have a high visual fidelity. And that's an important distinction that needs to be made when we're describing and specifying the level of detail for these kinds of projects. And this image shows it very well in the representation, how the level of detail can be tied directly to the actual work. And so this particular image, I want to give credit to where the source came from, was on a 3D case study report that FHWA had worked on.
Okay, I'll show the video now. Jeff, I'll play it and you can put it in the pod.
Okay, next slide. So Alexa, do you want to play that animation, please? As an example of our 5D application, so where we can see actual, okay, you can see time-based activities and the slider at the bottom of the screen. And we also have tied this directly to our cost data as well. So as the project progresses over time, and you can see what work is being demolished, what work is being planned, what work is being actually completed, it helps us manage the project activity in the work site much more closely. And it's very helpful for the field and for actual project management activities.
Okay.
Okay, Alexa, you can stop that.
All right.
Everyone can get a idea of how that works. Very good.
Thank you.
Okay. Very good. Thank you, Alexa. Okay. And lastly, with our K-Bridge, the project is complex, yet we have a lot of innovation involved with that project. And as I mentioned, it's on schedule, and our costs have not escalated at all at this time. Okay. I mentioned earlier about the Everyday Counts aid grant, and one of the important projects that we currently have for our using of civil integrated management and e-construction is the Kew Gardens Interchange Project, Contract 2B. We applied for and received an Accelerated Innovation Deployment, or AID grant, last year, and we're fortunate to receive this grant. And this grant will help fund the utilization of SIM modeling and integrating smart technologies, such as structural health monitoring systems, and we also have a weigh in motion sensor that's going to be used on this project. So what was important with this particular project was it's a design bid build project. Now we have, as you can see, because it's design bid build, we needed to create a 3D spec for the project, which included 4D and 5D applications. On the slide, you can just see a little bit of the beginning of how that spec is worded. I won't go into it, but we'll be using the 3D data all through construction for receiving an as-built as a deliverable, and then that information again will be used for asset management purposes. This is an image showing that where the project is located. It's down in Queens, and it's in between two major airports, the LaGuardia Airport and JFK. So it's a very, very important interchange that we have been working on for a little while. This is Contract 2B, the third of 4 contracts. So using SIM has been very helpful for us because we've also tied in the first 2 contracts, and we plan to use the 4th contract information as well. So it becomes quite an extensive set of data. So some of the other important aspects of this particular contract for us was the creation of the specification. And that caused us to really look deeply into what kind of level of detail was necessary for all of our three-dimensional elements and how we were going to tie all of this data together for construction's purpose as well as the asset management purposes further downstream. And so we are using CAD modeling as well as 3D GIS data for asset management. And I mentioned earlier, too, that we're going to be measuring our performance. And because it's very, very important to us, we want to be able to tell how well we are doing as far as using these technologies. So this slide just quickly illustrates the various performance measures that we're keeping track of. And as you can see on there, it's pretty extensive. The constructability, especially the biddability and buildability. And actually, FHWA is going to have a person or a staff person on the site working with us to assess the modeling and how the constructability is being affected by the model that we're using and how effective that model is helping us. So you can see the other performance measures, including schedule and cost, quality, project management capabilities, risk management, innovation, safety, and earned value. So to wrap things up here with this particular project, because this is a design bid build, it's one of the first times that we've shared a 3D spec, first time within New York State DOT for design bid build. And it's going to be very notable because this is also an important step for us in that we're sharing the 3D model as part of the contract documents. And so as construction utilizes the 3D model, we plan to see what we'll need to improve in future projects and how that's going to help with the overall completion of the project. The last thing I'm going to mention too is as we work with our contractor, we're going to be there sharing the data and just being able to answer any questions that they might have in regards to the 3D data deliverables, the 4D and the 5D deliverables as well. So we're very excited about this particular project. The bids were due today on the project. It's a best value, so the next step of the project will be all of the contractors who are bidding on this job have made their submissions, and the next process for review will be taking place after today. And
all right, thank you. Thank you both, Phil and Brett, for your presentation. So now we have our last poll before the Q&A. So I will bring those up. You have 2 questions on the screen to respond to. We appreciate your participation. Oh, okay.
Actually, I think we had these polls before, so I'm going to pull up the other ones. So I'm going to pull up the other ones in 3, 2, 1. Oh, no. Is it the next one? Bear with me.
All right. Well.
Okay.
Maybe we should open again the polls from the lobby just to make sure that everybody who joined a little later has an opportunity to answer those. If you didn't get a chance to answer these questions during before the presentation started, feel free to add your response now. All right. People are still responding, so we'll give a few more seconds. And responses are slowing down, so we'll take those in 3, 2, 1. Okay. All right. Well, thank you to all our presenters today. We will now start the moderated Q&A. You can continue to post questions as we go through the list that we have so far. And we are going to move things around a little bit, so give us a second. All right, so now the Q&A pod has moved to the center of your screen. We also have web links from the presentations today that you can look at later. All right, so we'll take the first question. Oh, sorry. Is that better?
Sorry, Alexa, can you just move your mic
First
a little?
question.
It's muffled again.
Drawing on cave walls or
There.
on paper from hundreds of years ago need only light and eyeballs to be usable. However, digital information recorded on 5¼ inch floppy or punch card not as easy to read. Have you identified the type of data that has more archival value? Do you have plans to protect archived information? Do you save a 2D raster version of final plans? Who would like to take this one first?
I can kind of go a little bit on what we've done for archiving. So all of our traditional plans that we've had, we've scanned into our ProjectWise system. And then also we do have PDF sections of the plans that we've got in ProjectWise as well. But as far as the 3D model goes, when we do away with plan sheets completely, we're hoping to have possibly a data that's actually universal that we could still use in the future as far as archiving. We're still trying to figure out how that's going to work, honestly. So, but we have in the past scanned all those in, and we do have those in ProjectWise. So it's paperless, but there's not a lot of information. We also have saved all of our CAD files that we've got in our ProjectWise system too. So if we stay with the same CAD platform and nothing changes, we can access those. But yeah, there is a potential that we could lose some data in the future, which we hope not to. But it is a possibility. Yeah, we went from Digimap to MicroStation. We had to convert all those years ago, about 20 years ago. So who knows if that's going to happen again, but hopefully not. So we definitely have to look at that.
Phil, do you have an opinion on this?
Yeah, I would agree that what Paul has outlined as far as what we are doing, many of the same things. We have a digitally scanned in copy of the plans, or in many cases the plan sheet, plan set is still our controlling document. So our 3D data is all stored in ProjectWise, and we have an enterprise database, enterprise-wide database. But we're still in the early stages of understanding how that data will be preserved long term. So our approach is to really create multiple sets of that data just to be sure that we still have copies of it in the future.
All right. Thank you. Most of the data you are collecting is 3D data. Why is this the first data you are capturing? Phil, would you like to take that one first?
Could you repeat that question?
Yes, absolutely. Most of the data you are collecting is 3D. Why is this the first data you are capturing?
I'm not sure if it's if I understand the question correctly. We are doing 3D survey and LiDAR scan for capturing 3D information because we believe 3D has more context and it provides more accuracy in 3D space. So I'm not sure if I'm answering the question quite as it was intended, but we believe 3D data is better information, higher quality information.
Okay. All right, I'll move on to the next question. Both presenters noted significant time savings. What do you attribute these savings to?
I could probably take this, or Tyrell might be able to talk on this too, since he was out on the SR20.
Yes. The question is, all presenters noted significant time savings. Why do you think, or what do you attribute the savings to? So what do you think made the big difference on the time savings?
So basically what it was is we were using a program called Masterworks to actually, record all of our data. And because we were using that program, we didn't have to do the traditional method. So our traditional method is basically using a Microsoft Word document on a laptop or a handwritten document. And when I came onto UDOT, I wanted pictures of everything, of all the work being done and stuff like that. And when I started requiring that, it made it really hard because they had to take a picture, then they'd have to email, they'd take a picture of their phone, they'd email it to themselves, and then they'd have to attach it to that Microsoft Word document or take pictures, print them out, and staple it to the document. When we got this new tool, basically what we were able to do is we got iPads in everybody's hands, and they could take those pictures and attach them right to the document that they were doing, and that saved a ton of time by doing that. In addition to that, they're able to stand out there, and watch the actual work being done, and they don't have to go back to their truck and type it all up on a laptop. They could type everything right there on the iPad while the work's being done. So, I mean, it was an extremely drastic change. My inspectors were, they were ecstatic to be able to do it this way.
I'd also maybe just add too on what you talked about on the change orders, and maybe you could go better on that, but basically by using that 3D model, we were able to have a faster turnaround time on getting things fixed. We could just send that to our designers. The new topo is perchance on what this one was. Send the new topo, let them rerun the modeler, send the model back to the contractor, and as Tyrell reported to me, basically instead of a 2-week time, it was 2 days for that change order. So that's where one of the big time savings were. And we're seeing too, just by working with our contractors and understanding what they need to deliver to them, not only are we getting time savings, but their biddings are becoming lower because they're able to bid the project lower because they have a little more confidence in the model and they can get those quantities down a little tighter. So that's another area. I don't know if you have anything to add on that, Tyrell.
Yeah, like that example you talked about on the blade. When we found out that they had not checked into their control, our guys were, kind of worried. They're like, well, they're putting in more material. The crazy thing about that item that they were putting more material on is it was, a planned quantity item. And what that means is we were going to pay them for a specific quantity. So we ended up saving the contractor money, and, because they were putting more material down than they should have in that area. And it was, across the, roughly 1,000 feet or so. So, it was starting to get significant. And when we figured that out, we didn't even have to call the RE or anything. All we did is, we said, okay, we'll bring another, piece of equipment over. We checked the two pieces of equipment against each other, and we could tell the bulldozer was the one that was off. Once we figured out the problem, we were good to go. If we were out there just using a tape measure, the inspector would have called the RE, or whatever that way, and we would have had to have a meeting and figure out why it's all a big deal. But we were able to solve it right there in a matter of hours. So that's, that was a huge thing, and I've seen it on other jobs where there's with this technology, with using the rover and using iPads and everything to back us up, it was so much smoother. You can't make up for what we were able to.
Phil, is there anything you'd like to add?
Construction stuff we did.
I'd just like to add that for time savings, as an example, one of many, for instance, on the Exit 4 project that I mentioned first with the AMG, field stakeout wasn't necessary. They would program in the modeling for the day early in the morning, and away they would go doing their work. And that's what the picture on the wall illustrated. All the colored stripes showed what work was being performed that day. So the contractor and our field inspectors were checking the work on a constant basis to see just whether the tolerances were there and the material was there. So that saves significant amounts of time, especially for the contractor in the field. And that's only one example.
Very good. Thanks. Okay, I'm going to jump to this other question. What survey data collection tools did you use in the SR20 project?
This is Tyrell again. So basically, we used a TopCon rover. That's what we basically used for data collection, period. And then we used iPads. I would consider that a data collection tool because they're taking pictures of, things were actually being constructed. But as far as survey data, we were using survey grade material, TopCon, working on Trimble software. Our inspectors were brand new to UDOT. The one guy, well, both of them had only been on like very small jobs before this one. And I selected them because, they were very able to grasp the technology and just move with it. So that was kind of what we used, and maybe a little bit about why we used those devices. Also, one other note is UDOT did require the contractor to provide the equipment, and I think that was a very intelligent decision. By making them provide the equipment, they're responsible for the equipment. If we were to break it, obviously that's on UDOT, and we would have to work something out there. I don't know if we've got a provision there for that. But they were responsible for training us on it, my guys and everything. They were responsible for maintaining the equipment if it did break, whatever that way, or if there was a software issue. And the contractor was, they're always using this equipment anyway, so they have connections and all that stuff to get it fixed, whereas UDOT, I think that if we had something break like that, we would send it in and not see it for a while. The contractor, they send it in and they're able to get us something up and going. I think there was one time when we were without a rover for maybe a day, and quite honestly, that really didn't hurt us any at all. And so by having the contractor provide that data collection, hardware and software, et cetera, it was very convenient for us. And maybe one more thing to add to that is a lot of contractors are, they are up to speed and they've got the latest and the greatest technology. If UDOT were to purchase something, we'd probably be sitting on it for years and years and years. And when it gets old and is no good, what do we do with it? Whereas the contractor, they've got the ability to trade all that stuff in or, and get brand new up-to-date stuff. And they're always kind of, seems like some of the, the higher-end contractors are always trying to...
Yeah, the question was, what survey data collection tools do you use, did you use in your project?
We used total stations, digital levels, GPS units on an average project. It's all based on your spec. If we're requiring the contractor to meet a 1/4 inch per foot, your GPS unit doesn't shoot a 1/4 inch. It's an inch, plus or minus. So you got to use the right tool for the spec and the requirements that you're making them adhere to. Like concrete paving, we have to use a total station or level to get the accuracy down. Earthwork, we can use a GPS unit, which is funny because we could check everything but fine grade using the GPS unit. Then we've got to bring the total station out to check fine grade. So we use a combination of equipment based on the spec and what the accuracies are required.
All right, thank you.
Yeah, that's on an average project. We do have a couple of cases.
That's on an average project.
Yeah, we're some exceptional projects like Kew Gardens. We actually went out and scanned the entire project. We needed for some more more accurate, more finite detail, and to confirm the original ground is what it is. It's New York City, the middle of Queens, and not a nice neighborhood. Things move all the time, whether they want to or not. So we just wanted to make sure we confirmed with the design group that this was actually what's out there as of late spring, early summer of this year.
Okay. What software and what challenges did you experience with transferring data between survey and CAD?
As long as the land XML, we didn't have any problem. And that's one of the discussions we have in our pre-construction meeting with the contractors. What data format do you need, and how do we get it? So we basically agreed to come up with a land XML transfer, and we haven't really had any problems.
And the land XML is what you have on. I'm sorry, go ahead, Tyra.
This is Tyrell again. Sorry. No, I'm sorry. I was just going to say we were using MicroStation, or Open Roads to do the design work, and we actually had some issues transferring that from Open Roads into Trimble, trying to get the 3D data to go through. We ended up having to go back to the land XML files to transfer it over for this specific job, so the contractor could, build their own models and what that way. So, in my personal opinion here, and this isn't, representing UDOT, but this is my opinion and from my experience, I think if we would have been using AutoCAD, I think that things would have transferred a little easier. And UDOT is experimenting with going to using, Civil 3D and stuff like that. And we're kind of up in the air on where we're at there. I can't speak fully to that because I'm not, on the design team. I'm just in the field, but I work very closely with the designer for this project, the entire project, and I know Civil 3D pretty good, but MicroStation
We have the same
And I can
problem
speak.
because
really
we
kind of
moved
probably
the
held us back on some things as far as the design and transferring it to survey
we
goes.
moved the Trimble export function. That's why we went
Yeah, and I
back
can
to
speak.
XML.
That makes sense, yeah. On what we're doing, so to kind of talk more on what Tyrell's talking about, we're actually, on some of our projects right now, we're dual designing, so we're doing it in AutoCAD and in MicroStation both. Where a lot of our problems came from was the new open roads. It's got a lot of bugs in it. It was crashing constantly. We've been working with Bentley to try and figure those problems out, but it didn't help on SR20 because we had so many problems. We were trying to use the I models and that converter to go straight to Trimble, but the triangulation wasn't working at the time. Since then, they have fixed that piece of it. So we did have a lot of issues in the translation from MicroStation into Trimble Business Center. So luckily, like I said, they have fixed some of those problems, but we did have to go to Land XML on that. We're hoping to see what we can do in the future. One of our contractors, Clyde, they have said that they actually started seeing towards the end when both Trimble and Bentley was working together that the I model started doing a little better translation than the XML did. We had a meeting yesterday with Bentley, and they said they've found sometimes on those XML files that if you don't clean out your surface completely and then export it, that you might get some ghost stuff, because we were getting ghost surfaces and some other problems in there. But if you empty the surface first and then send it out, then it seems to work better with the XML. But there's definitely some problems in the translation and with the programming where it's at. So we're hoping to get those problems fixed, but that's why we are doing a dual design in both systems, because our contractors are using AutoCAD. They're translating it from it quite easily, is what we're hearing. So we're trying to look at both packages to see if maybe AutoCAD's the way to go or if we stay with Bentley. So we're still not sure where that's going yet, because we have had some crashes with Civil 3D as well. So that's something we're definitely looking at.
Okay, great, thanks. Moving to the next, we have about 2 more minutes before the webinar ends. Who put together the 5D info? Was it the contractor schedule and cost? So I think this question is asking for the K-Bridge, maybe, who put together the 4D, 5D information? I might have. Okay, well, we'll move on to the next question and see if we can get them. Oh, they're back on audio. Are you guys on?
Okay.
Okay.
So I know the
Alright.
answer to that question.
Next question,
from
how did
working
you
with them,
get
so I'll
input
type it in
for the
to
new
the,
specifications for
Q&A.
the
We can move on to one more question
KGI
while they
contract?
figure out their mic.
Did you obtain feedback from multiple sources before implementing? Yes. Did you want to take the previous question? Or this one, we only have about a minute. So the previous question was, oh, did I lose you again? Okay. I can hear you now. Yeah, I can hear you now. So first question was, who put together 4D, 5D info?
Can you hear me? Okay. Okay. The 4D, 5D info on the K-Bridge, that was the contractor. We had included that in our proposal. And again, that was a design build project. So we stated in the proposal what our deliverables were, and the contractor did that. So for the Kew Gardens, which is design bid build, we put together a spec that details all of that information. and what formats, what file formats,
Okay.
and what
All right.
deliverables are to be provided.
It is 1 o'clock, so can we answer one more question, Ches, or are we going to lose audio? Okay. Do you guys
think that
have...
we can stay on the
Okay.
line if everybody is available. and we
Okay,
can
so
run
there's
over.
another question regarding the New York projects. How did you
Go ahead.
get input for the new specs for the KGI contract? Did you obtain feedback from multiple sources before implementing them?
Yes, we've been getting input from various places for the last year or so to incorporate what data should go into the spec based on our experience with our design build projects and the proposals that we had put together for those projects. So in effect, we did have the experience as far as what needed to be included in the specification. We've also been working as part of our Everyday Count stick grant. We also have an implementation plan for SIM, and we have a consultant involved with that. And there's a lot of information we've been sharing in regards to things like level of detail and what data formats need to be provided for sharing them. We also have had, this is a very, very important point, we've had meetings with contractors to actually ask them what do they need for building a project out in terms of the 3D data.
All right, we'll
And
take a
that's
couple of
been
more
very
questions
helpful
and then
as well. That's why we refer to it as the customer chain.
All right, so we'll take a couple more questions. Are you aware of or have you used any technology to scan underground utility information in 3D?
Yes. That's part of our deliverables as well with the Kew Gardens, is to capture all the underground utilities. Those are utilities that they're going to put in the ground, as well as any utilities that they uncover. We want to know their exact location within a specified...
All right, we'll take one last question. With multiple inspectors adding notes and comments about the contractor's activities, does the RE review them, or are they added to a daily diary as separate notes and comments?
So as far as, this is Tyrell, as far as the Masterworks program goes, the RE can review them, but how it works with us is each inspector is filling out their own daily diary, and so that inspector, I guess that wouldn't really apply to the documentation that we're using, because what we do is, so Gabe, he would fill out his daily diary and turn it into the FE, and then the FE, I would approve it, and then the RE could also look at it and approve it. So if either one of us looked at something and didn't feel like, you know, there was something in there that was not fully representative of what may have happened that day, we can always kick it back to the inspector who wrote the document, and they have to give us more detail or explain the situation a little better, add more pictures, stuff like that.
Right.
That's essentially what we do in New York as well. It
Right.
gets reviewed at the end
Thank
of the
you.
day.
I realize we are over our time, so thank you everybody for the questions and staying online. Just a few more things. E-construction is moving forward in EDC4, so their sneak peek of EDC4 in the next webinar, webinar 6. Our next webinar is in January. E-construction and partnering is a vision for the future is what goes on EDC4. Regional summits are underway, and webinar recordings of the EDC4 virtual summits are now available on the FHWA page. And now, which is like your feedback, so I'll bring the evaluation. We'd appreciate if you can take a second to respond to that. Thank you. Right. It looks like we lost quite a few people as 1 o'clock came by, so we appreciate that. We'll take those away. We do have PDH certificates. It takes about 24 hours for the request to be handled. It is a Google form, so if your agency blocks Google Forms, you're not going to be able to fill that out. Just be aware of that. And last, just want to let you know that we have 3 more webinars. The next one is on prioritizing e-construction investments, and it will be on January. All the information and the pre-recorded webinars are located. You can find them on econstructiontoday.com. On behalf of FHWA and MDOT, we would like to thank you for attending today's webinar, and we look forward to having you attend the next webinar. Thanks, everybody.